Today's engineering forum, I've already posted the document for what we're going to try and cover in today's forum. So that's out on Integration Point. As well, if you wanted to follow along, you can. But, all right, so just a disclaimer. I may not know what I'm talking about, and so you don't have to call me out on it and let me know. I'm telling you right now, I probably don't know what I'm talking about. But one of the reasons I wanted to look into this topic is there's a lot of buzz around functional programming and functional versus object-oriented and which one's better and why. And so as I started digging into it and learning a little bit about it, it was interesting to see how much functional, how many functional programming concepts exist already in .NET, and it's a nice little hybrid of functional and object-oriented. So I thought, well, I want to learn a little bit more about that and learn what's available and why it's there and how to use it and what it's for. So I decided I would approach this topic, and I learned a lot along the way, and stuff that I'd been using all along and didn't realize I was using. But I'm by no means a functional programming expert, so don't expect that from me. So C# is a beloved language. A lot of us, who all here uses C# in their day-to-day? Yeah. We love using C#. It's a great language. It was initially released back in 2002. Version 1 was released, and you can kind of see, I don't know how much of that you can read, but you can see over time that in the different versions there were different features that were introduced into the language. And we say the language, but it's both the language and the .NET framework as well. So there were parallel releases with the .NET framework. The underlying framework is really what supports this, and then the language is the features that sit on top of that framework. So many of these similar things are available in other languages that sit on top of the .NET framework, like Iron Python. In fact, a lot of the functional stuff that was put in the .NET framework was to support Iron Python and F# and some of those other functional languages. But C# has been able to kind of take advantage of some of those things. You could debate whether it's truly functional or not. I don't know. I'm not a purist. I just read Wikipedia like the rest of us, right? Couple of the key things that were introduced really quite early. In 2005, anonymous methods were introduced. The volatile keyword, which isn't really essential to this, but how many have used the volatile keyword in their development? Yeah, nobody, right? I had to go look that up and say, what is that for? I still don't know. Implicitly typed local variables, extension methods, lambda expression, type inference, some of those things, anonymous types, automatically implemented properties, expression trees, clear down in 4.0, and we're not going to cover it today, but we could have a whole discussion on dynamics of the DLR. So the CLR we're all familiar with, but the DLR is the dynamic language runtime that was built in, that was added for in C# 4.0, and there's some really cool things with dynamics and stuff like that too. But we won't cover that today. 5, async and await, 6, 7, and it just keeps moving on. The language keeps progressing. So the key features that I think will affect kind of some things we look at are here on this. DLR and dynamics, not so much, at least it's not obvious when we're using it. Under the covers, it's being used a little bit in some of the things that we're doing. Okay, so before we go into that, let's go just take a look at a simple contrived example. So I want to take a look at what our code would look like in C# today if we didn't use any of the cool fancy features that we use every day in our coding. So let's just write this really stupid contrived example. So I'm going to have a string array called numbers, which is really not numbers because it's an array of strings. But anybody remember doing that? Whoops, I guess I should put it in some sort of a method. Where's my method? Oops, I'm in a class. That's not where I meant to be. Sorry. Let's go into here. Yeah, okay. I just have a console application. It's a .NET Core console application, by the way. So an array of strings, now I have to fill it up. I mean, if this is feeling tedious already, it's because it is, right? So I'm not going to type all those. Let's just copy some of these in here. Whew. Anybody like doing it that way? Kind of sucks. Okay. Then the next thing I want is an actual array of numbers. Yeah, you like that? So now I'm declaring nums as an array of integers. And then what I'm going to do is I'm going to loop through our numbers array, which is an array of strings. And then I'm going to parse those, and from numbers into, or from strings into a number. And then I'm going to add 10 to it just because we can. And then, because we want to see that what we did actually worked, let's write that out to the console. Okay, let's run that. Yay, there we go. So 52, 20, 19, 37, and 20. So it worked, right? So that's excellent code. That's the kind of code we love to write every single day. Except no one likes to write that. Okay, let's add a better version, right? By the way, I'm using the W keyword. I think everyone's familiar with that one, right? No? Oh, because it doesn't exist. It's just a static method that I wrote down here to help output my stuff. Okay, so everyone should have a W keyword.
Is that in the .NET stack code?
Yeah, we'll add that to the stack. I mean, because who doesn't want W, right? All right, so now let's rewrite this a little bit better. Using some of the newer features, let's do the var keyword. And before John jumps down my throat, I don't want to type any of this. Forget it. I'm not typing. It's too much work. I'll just paste this in. All right, so let's look at that. And let's fix any of the mistakes that I made. Oh, turns out you can't use var there. Oh, I already have it declared, that's why. Never mind, you can use var there. So let's just get rid of this stuff up here. Okay. Cannot initialize an implicitly typed variable with an array initializer. That's right. Okay, so now it's happy, right? So this is a little bit more concise. So let's look at some of the features of the language that we're using here. We're using, what are we using right here on this side? Using like a array initializer. Yeah, so that's kind of nice. Beats having to write. I don't have to declare the size of the array. I don't even have to declare that I'm creating a new array. So there's no new keyword. There's no string array, and then there's no size of it. It's all just auto-initialized based on the right-hand side of the operator and what's in there. So that's cool. I like that. On the next line, we take numbers, which is an array, and we use the dot select keyword. And where does the dot select keyword come from? Yeah, it's a link. It's a link extension, right? And using a lambda expression, int32 parse m plus 10 dot toArray, dumping that into nums using var keyword, which I think this makes John unhappy. He would rather that be an int array, right? But I like vars. And then for eaching through the numbers and then console write lines. So we've reduced the amount of lines pretty significantly, but so how did we get here? What's going on? I mean, it's better, it's still contrived, but it's more concise. So let's see. There's some functional things that we're using here. We're using lambdas, and we're using the select out of the link library. But why, before we jump too far into it, why use functional programming styles in C# anyway? Well, if I go back to the slides for a second, this is what the internet said. for code reuse, ease of testing, concurrency, and I added the last one, it's trendy. So there's 4 good reasons to use functional programming styles, right? That's pretty good reasons. 3 really good reasons, and concurrency. All right, okay, yeah, good. So when we talk about code reuse, we can reuse we can reuse utility functions, which will result in smaller code. So if we were to break down select and see what was happening inside of select is nice. It's reusable. We use it a ton, right? We use .where a ton. We use everything in the link library a ton in our coding these days, and it's really convenient because it's reusable code, and it's functional. And if you get into like definitions of what's a pure function and all that kind of stuff, it makes it easier to test, basically, because you can input a value and you're going to get a certain value back out of it, and it should always return the exact same value every single time. It's an expected behavior. So then for concurrency, now this one was kind of interesting. I hadn't really thought about it, but let's see what it says here. It says, if we stick strictly to a functional programming style and make sure there are no side effects, our code is thread safe by default because each thread will only be accessing objects instantiated within its own thread stack. And so there will be no objects having 2 threads trying to access them at the same time. So there you go, concurrency. And then it's trendy. Everybody's doing it. Somehow there's a belief that you can either write functional style or object-oriented. Turns out you can actually write both, and most of the time you should. There. How's that? Anybody happy with that? Okay. All right, so let's go on. So one of the key components of functional programming centers on the idea that functions can accept functions as parameters. C# achieves this through the use of something called delegates. So delegate, what is it? Well, it isn't manna, right? A delegate is a type which holds the method or methods reference in an object. It is also referred to as a type-safe function pointer. And here's the declaration. Public delegate, return type of delegate, name. I don't think I finished that. And the rest of it. Oh yeah, no, it's there. Return type of delegate name. What I don't show is that it can also take parameters. So an example is public delegate, double, number operator, int A, int B. So what does that really mean, I guess, is a good question. So let's look at, I mean, how many people really understand what a delegate is and what it's doing? Okay.
We do it all the time in our lambda expressions as an anonymous delegate.
Right. We're not to that part of the presentation yet. Jumping ahead. All right, we can go. Thanks, everybody.
No, this is what you had to do before back in.
Yeah, so I'm trying to show you all the sucky parts, right? The way that we used to have to do things. All right, so what's a delegate? So basically a delegate is this, and I think the best way to kind of show it would be like this. So let's say I have this method down here, this private static void W. Let's say I wanted to hold on to that W method and assign it to a variable. Okay, so we'll just call it variable hold my method equals W. Well, how come it doesn't do what I want? I want to stick it in there. I can stick all kinds of things inside that variable, right? But why can't I stick the method? I can't stick a method inside of there. I can. What's that? Because it's not JavaScript. Right, that's one good reason. Okay. So in order to hold it, you have to declare a delegate to hold it in. So let's go ahead and kind of do that. I'm not going to do it for that one, but let's create this number operator one. I hope this works. So a delegate looks like it's a signature that kind of defines the shape of a method. So this delegate will be a variable, I guess is one way to look at it, a variable that will hold a pointer or a reference to another method that accepts 2 integers as arguments and returns a double in the output. So let's create this class. Let's see. I'll just copy this right inside of here. Okay. So I have a couple of methods. They're static methods. I have one called multiply values and one called add values. And in this method, they just take parameters, 2 integers as parameters, and they'll return a double, or in this case, they'll, yeah, just assume that it's returning doubles. Let's not get into that nonsense. And then I'm going to take this code here and drop it right inside of our thing. Let's delegates. So what I've done is I've taken this variable, I don't know, typo, multiply, and I newed up a new delegate. So this number operator is a new delegate, and I'm passed in the name of this method, multiply values, in to the number operator as a delegate. And so now multiply is a new variable that's essentially pointing to that method. Does that make sense? I'm sure this is, I did the same thing with add values. I newed up another number operator delegate and assigned that to the variable add. Later on, I can invoke that just by calling multiply and passing in the 2 parameters, v1 and v2, and the same thing with add result, and then later we can write that out. So let's just run this and see if it actually works. So it wants me to enter a value, so we'll enter 12 and 4. So the multiply result is 48 and the add result is 16. Okay. Is that good so far? If we look at that code and see what's going on. So that delegate is interesting, but it's like, yeah, so what, right? I could have just called that method. It'll make sense a little bit later as we moved onto a kind of anonymous stuff. And anyway, we'll get there and it'll make a little bit more sense. So let's change this up just a little bit. What I want to do is, instead of having to create these methods and then have these delegates assigned, I want to do it a little bit differently. So let's take those out. And then let's do this. So what's it unhappy with? That should be happy, right? What's it unhappy about?
You declared them later.
Oh, I do. Okay. It really doesn't matter what these are called. These are just placeholders, right? Okay. So I'm kind of on the fly creating these delegates. So I don't have another method that I'm going to point to that's declared somewhere else. I'm declaring the method inline, kind of on the fly, using the delegate keyword. And the shape of the syntax is delegate. Here's the input parameters, and then here's the operation to execute the multiply operation and the add operation. And so this should produce the exact same results. So if I do 12 and 4 again, I should get 48 and 16. And I do, so that makes me happy. All right, so that example, it doesn't feel like it saved us really very much, and it really hasn't. Like, it's not a ton of lines less or anything like that. But it introduces the idea of anonymous methods, which we'll use later in a more concise way. So I'm going to take all this out because this is just, it just feels verbose to me. And we're going to take, we're at intermission, so let's do an intermission. For intermission, one of the things that we look at here is, notice this up here, for each var n in nums console write line n. I would really like to make a utility function or a method that would be more concise, because I don't want to write this over and over again today. So let's just do that. So let's add a class. And I'll just call it utility functions, I guess. And I'm going to make it a static class because this is going to be a static method that I'm going to add. And so I've just created a static method called console write of type T, IEnumerable of T, items for each item in items, write line item. Okay? So now we've introduced the concept of generics here. So basically it says I can take an IEnumerable of whatever, and whatever you hand me, I'm going to loop through that and I'm going to write that out to the console. So that's going to be really handy because I hate writing that over and over again. So let's just change this. So now instead of doing that for each, I should just be able to do a console. Right, if I can type. And just hand it nums. Oops. I know, but I thought it would add it for me. I must have mistyped something. What is this?
You can hover over and hit the light bulb.
Yeah, it didn't work. Where did it put it? It should be in there. Oh, it's in the same namespace. Oh, good point. All right, utility functions dot console write. Crap, I give up. There, whew. Okay, so I like that a lot better because that's more concise. Let's just make sure that that actually works. And it did, it output all these numbers, except what the heck is 111? Did I add something in there? Oh, 101. That's supposed to be, what was that supposed to be? I think it's supposed to be 01. I think that's what it's supposed to be. 52, 20, 19, 37, 20. Okay, excellent. So everyone happy with that? They like that a lot better than writing for each time. We'll just use our utility function. So now we have reusable code that we can reuse again. Okay. Well, that's really nice. But one of the reasons I'm going here is because I want to introduce the next concept, which is extension methods, right? Extension methods can help us out a ton. So let's go take a look at extension methods. What is an extension method? Well, it allows you to add methods to existing types without creating a new derived type, recompiling, or otherwise modifying the original. The link library is essentially a collection of common extension method types that are attached to the IEnumerable of T types. So, okay, very cool. So let's convert this utility function we wrote, utility function.console write, into an extension method, right? Because at the end of the day, what I'd really rather do than write all this nonsense out is just type nums and then do a .toConsole. So let's change our utility function to do that. So the first thing is, let's rename this to a toConsole because that would be better. And then to make this an extension method, what do I need to do here? Anybody? Just add this keyword right here, right? So it's still the same function, and believe it or not, I can still call it this way because it's still a method. It's still a static method that I can call, and I can call utility functions.toConsole. But by adding that keyword, it gives us the benefit of being able to call it like that. So I've just extended the IEnumerable namespace with my own function that I can attach to there. And there are several benefits to that. It becomes discoverable. So anytime you have an object like that, you can hit dot and IntelliSense will show you the extension methods that will work on it. So let's just check, make sure that this all still works, and I'm pretty sure it does. Anybody think it won't work? Right? Okay, works. That's fantastic. So link is, like I said, a collection of nothing more than a bunch of extension methods that are based on the IEnumerable type. That's really what it is. And what's really cool about what they did recently with .NET and C# is when they open sourced it, you can now go and look at all the definitions of the link library and see how those things are constructed and built. So that if you need to write utility functions that are similar to link for your application, go look at how the actual link implementation is written, and you can kind of copy and steal a lot of things from there. Okay, so that toConsole extension method is very cool. However, what if we wanted a more general purpose extension method? Maybe we don't always want to do a toConsole, but I do want to do some kind of a for each activity on every item in a list or an enumerable. How could we write an extension method that would basically execute a for each, and anything we passed into it, it would just perform that operation on it? So let's see if we can. Let's try to write one. Better yet, let's try to paste one in. Okay. So here's a for each that I've written, and this is a mutable version of it, and it doesn't actually, it returns void. So oftentimes if you look at like link extensions, it returns out another IEnumerable that's different than the one you passed in. In this case, I'm actually literally going to change each value in the list that you hand me, and then your reference to that list will just be new and different. You won't have your original list anymore. So on this for each, we pass in the input is IEnumerable of items, and then we have an action type, and then the action, whatever we pass in, will get invoked right there, and it will run. So let's just first check it, make sure it actually does something. So this will be called our for each extension method. And what we'll do is we'll do nums.forEach. And the action we want to do on that is, what did I want to do there? Let's just do a console.writeLine. So we're actually going to just pass in the same method delegate and run that. So did the exact same thing, but it's reusable, right? So I don't have to just do toConsole. I can pass in anything I want inside of there. If I wanted to do a debug, what's the one? Debug write. I could do a debug write, and it would write it not to the console, but to my debug output window or whatever. So for each allows me to kind of do stuff on it. Let's do one other in here. Let's do another for each on this. Let's use an inline delegate. Okay, and then we want to see that outputted to the console. Did I miss a parentheses? Oh yeah, that's right. Returns void. So we should be able to do toConsole on the nums because it should have been modified, right? That doesn't look right. It didn't modify it. How come? Okay, well that didn't work. So don't do that. Not sure why. So what's that? That's what I thought the M was, right? Well, I don't know. I'm not sure what I did wrong there. But we can fix this.
Isn't it because you're a simple value type of an integer? So it's just a value type going in, so you're changing into the space of that function, but you're not changing the value in the array. Because value types like ints are copied into function signatures, not pointed to.
Okay, so
If you do add instead of multiply, you might do it.
No,
No.
Still the same thing. You just, if that were an object, then you'd be passing a pointer. But as a value type, the compiler just puts the value into this.
Oh, that's right. That's a good point. Okay, so this example is not a good example, but what I really wanted to demonstrate here is that you can pass in an inline delegate this way instead of just passing in a pointer to another method. And the reason that's important is we're gonna build on that in just a second. What we want to do is use the let's first go back and just talk about what action is, right? So I use this action keyword here. What is an action? What is action as far as a keyword? Anybody know what that is? So there are three of them that we'll kind of look at today: action, func, and predicate. These are special predefined delegates, if you will. So they're kind of shapes of methods that match. So action of T is a delegate that doesn't return anything or returns void. So any type of an action, like a console write line, it does a thing, it does an action, but it doesn't actually return a value back out. Func, its shape is you hand it a source and it will return a result. So and the types don't have to be the same. So those generics there, T source and T result, you could hand it an integer and return a double if you wanted to, but it's a delegate that returns a result. And a predicate is basically a special form of func in that you hand it a source and it returns a Boolean type. So if you've used the link library, .where, or if you use the lambda expression inside of like .first or default, that is basically a predicate. And sometimes you'll see it when you go type, it'll say it's a predicate of type func t, bool. So what you usually pass in there is some sort of expression that's going to return a Boolean. So in your where clause, a lot of times you say where, person dot age is less than 10 or something like that, and that's how that gets translated. So that's what action, func, and predicate are. They're just special delegate types. So in this case, I'm saying you can hand me any action that doesn't return anything, and I'll just execute the action for you. So that's what that does. All right. So let's modify this a little bit. So this didn't work because of funny reasons, but we want to introduce lambda anyway. So let's talk about lambda syntax a little bit. Our delegates combined with extensions give us some pretty cool powers. However, the anonymous delegate syntax for each feels really verbose, especially if we've already used lambdas and we know what they are. Using type inference and a whole bunch of really fancy features in C#, inside of this parameter, this action parameter, we really don't need to tell it it's a delegate. It's expecting a delegate. So we can take the delegate keyword off. We also, because of type inference, we don't need to tell it that it's an integer. It already knows that the nums is a list of integers anyway. And using the fat arrows, which is part of the lambda syntax, I can do that. However, I really don't need the parentheses around here anymore because that's not doing anything for me. So I can take the parentheses off. And I don't really need to have these curly braces anymore because those are unnecessary. And since it's a single line, it doesn't need a semicolon. And voila, you have a lambda syntax. So what I really want to demonstrate there is lambda isn't really anything magical or special. It's just a shorthand notation for a delegate. And a delegate is just a pointer to a method or a method that you created in line. So that's really all that's going on there. Now, out of curiosity, I wonder if this actually works. No, that's cool. Who cares, right? But anyway, that's kind of how that works. So let's move on to a little bit more complex example. So far, all of these things have been on primitive value types, but most of the time we want to operate on an IEnumerable of a reference type, something a little more complex. So let's introduce our person class. Okay, you with me so far? All right, so I have a simple person class, has a person ID that's an integer, first name, last name, and an age. Notice in C#, it's really cool. We have the setter syntax is really is nice. We'll just leave it at that. So let's, in our program here.
You need to close your namespace background first.
Oh, thank you. My namespace? Oh, it's closed. It's way down here. I have secret code hidden down there because I didn't want to write all that later. All right, so I cheated. Okay. It's a good thing, too. Okay. So we can use some other really cool features combined together. I'm not looking, so I don't know what's really coming out. It'd be interesting to look back and see what I've just written. Anybody believe that?
You missed a page.
I did mess it up.
Close quote needs to go at the end of Spencer.
Yeah, that's pretty good for not looking, though, right?
What, I think the age is wrong too. Shouldn't that be 52?
Something like that. We're going to go with 22 because we can fix that later. All right, so we've seen this before. This is really kind of nice. So I just newed up a list of persons, and then I did person.add, did a new person inline, and then used a, what is this called here? Auto property initializer or something like that? Is that what it is? Yeah, okay. I'm not really good at naming my code, but what it is. But so that's pretty cool. We can create an enumerable like that. So I don't want to do all this by hand. So I'm going to help it out. I've got already in here another class called roster to make it easier. And let's just get rid of that for now. Yeah, that's fine. Okay. So really I have a roster. I just have a bunch of people and names in here already, and we want to pull those out and enumerate those. So get rid of this and just say var roster equals new roster. And then I'm going to just do a roster dot, let's see, persons. And so let's put that in a persons object. Var persons. Don't bristle, John, it's all right. Okay, and I just want to use our cool little toConsole function and output all those people's.
You change your W function?
No, I don't really care. All right, so did we get what we wanted? No, we didn't get what we wanted. How come we didn't get what we wanted? Okay. Yes, you're correct. So let's just fix that real quick. Because it's a reference type, and all reference types inherit from object, an object automatically implements has a two-string implementation for us, and the default two-string implementation for an object is simply to output its name, the name of its object. Not terribly useful for us. So we'll override the default implementation of two-string, and we're going to use, we get bonus points here because what did I use on line 19? What syntax is that? It's string interpolation, right? And that's new from C#6? Yeah, so C#6 introduced string interpolation, so that's going to be awesome. So let's run that now. Ta-da! Is that much better? What do you think of that list? John, how old are you? You're not 41, are you?
40.
You're 40? Sorry. Made a mistake on your age. That's okay. But you're also 39 down here, so on average you're 40. Does that work? Okay, cool. Let's see here. Let's use some link methods in here and have a little bit of fun. Let's go. I can't remember if this works. I don't think this works. Will that work? Average age of that group of people is 41.222222. So that did work. So look at all the fancy stuff we're using there. String interpolation inside of the little curly braces. We're calling this person enumerable. We're calling from the link library a dot average. We're using a lambda expression, and what we want to average is the ages. So, okay, that's pretty cool. I like that. Let's do this though. One of the things that we've been told is we have a requirement to protect sensitive information about our users, and age is one of those protected values. So we'd like to create a full name. We'd also like to create a full name field for ease of use for our consuming applications, and we want to basically hide the age from our consuming applications. So we're going to use .select. And we're going to do a new ID. We still want to pass the person ID, right? And let's do a full name equals p.firstname plus, we have to have a nice little space in there. Oh, that's terrible. Somebody stop me. p.lastname. And then we'll still need to pass the first name and last name separately because this is going to go to JavaScript, and eventually they'll need to be able to sort by first name or last name depending on what the user wants to do. So that looks good. And then let's output this to the console and see what happens. So what have I just used right here? Can anybody tell me what I just did with this new keyword right inside the lambda? Anonymous type, right? So this isn't a class that I've declared anywhere. I've just kind of declared it on the fly within the middle of my lambda expression. So I have a brand new type. It's a new shape, a new structure that we don't have defined anywhere. What do we think will happen when we run this? Oh, sure, wait till it ran. Okay, so that's kind of cool. So anonymous types, their default two-string implementation automatically outputs it like that, which is kind of nice, isn't it? That's pretty handy. And you'll see we no longer have age output as part of the object. It's hidden from us because it's a brand new object that we created that doesn't have age as one of its properties. So that's convenient, but how many of us actually like to write this kind of stuff over and over and over again everywhere? So everywhere that we're going to deal with the person, because our requirement says we can't have age handed out, do we really want to do an anonymous type over and over and over again? Occasionally it's okay, but I think it's kind of a pain. So let's not do that, because that is convenient occasionally, but if we're going to be using this a lot, let's create something called a person view model. Everyone okay with that? And to make it simple, we'll just copy and paste this in here. So we have this person view model. You can see that the structure looks exactly the same as I had before. Now let's go back to our program. And what can I do here? I can create a new person view model. But I still have to go through the pain of doing all this assignment, right? And that's still... So there's an idea, right? We could put a constructor on the person view model that does all that mapping one time, and then I never have to do it again, right? So that's one way to do it. What's another way we could do it? Any other ideas? Okay, we could do it that way. I want to show you another way to do this. So what I want to do is use a static implicit or an explicit operator. In this case, I'm going to create an implicit operator, and we can talk about later whether that's a good idea or not. So this static implicit operator, what that does allows us to cast an object from one type to another, and the compiler will know how that cast is supposed to work. I've just taught it. It said, hey, anytime you're casting from person to person VM, this is what this means. These are how the properties line up, right? So that's what that does. What that allows me to do inside of a Lambda expression like this, oops, is, what am I on a Mac? Knock that off. Okay. So instead of creating a new person VM, what I want to do is take P and cast it as a person VM. So I can just simply use, that's an explicit cast. Even though I wrote an implicit operator, I'm using explicit cast right there. But one of the things that'll let me do is stuff like this. So if I say person VM, VM person equals, and I'll just take persons dot first or default. That's implicitly casting for me, right? So that's kind of cool because the return value from here is a person, but I'm putting it into a person VM. So the implicit operator allows me to kind of do stuff like that. Now does anybody think that's a good idea or a bad idea? What's that?
I was going to ask if it uses reflection to do that, because that might slow it down quite a bit.
So it doesn't use reflection to do that because we actually just defined it right here. So it's pretty simple. It just news up a person VM object. We told it exactly how to do the mapping and the casting. So it's not really heavy that way. But you could have some strange side effects when you use implicit operators. Usually implicit operators work well for things like you can put an integer into a long. You can put a short into an int. And the reason you can do that, and it implicitly will cast that for you, is because it's safe to do so. But if you were to do the other way, I want to put a long into an int, that's not safe to do, and it won't implicitly cast that for you because the long might be bigger than the int can hold, right? So in those scenarios, implicit casting like that can be a bit treacherous. Now they've allowed us to create implicit operators for simplicity's sake, but we need to be a little bit careful about what we're doing. If we could possibly cause problems by doing an implicit cast like this, then we may want to consider not doing that. So the other option is we could just do, an explicit operator for casting, and that will still allow us to do this type of a cast, but it won't allow us to just implicitly cast like this. We have to explicitly say this is going to be a person VM. Is that pretty cool? So when did the implicit casting come in? I don't know, 3. It was pretty early. It was quite a ways. It's been around for quite a while. So the static implicit operator. So that's really helpful though for us to be able to have that and be able to cast objects around like that. So I just wanted to show that little feature. I thought that was kind of cool. All right, so that's a lot cleaner than doing an anonymous type everywhere. So let's look at one other thing really quickly. How are we doing on time? Good. Okay. I distinctly recall when we ran this, so let's just run this real quick.
That clock is slow.
I know. I'm adjusting. So we have the same problem with person VM, right? We don't have a two-string implementation for that. So let's just go back to our person VM and put a two-string implementation in that we're happy with. Let's start by borrowing this one. And there's no age. And really, let's just use full names so that we know that full name is working. Double check that, make sure it works. Okay, yeah, person 1, Travis Mayer, Tony Spencer, all that kind of stuff. All right, cool. So everything's still happy, but let's look at something else here. I'm going to get rid of this for just a second because I don't need person VM. We're going to go back and look at this list again. So you noticed in this list we had duplicates, right? Does that bother anybody? We have Travis Mayer, who's 35, Tony Spencer, 48, Jim Byer, 53, John Worthington, 41. Then we have another guy called Travis Mayer, who's 36, Tony Spencer, who's 46, John Worthington with an H, who's 39, Jim Byer, 53, and Travis Mayer, who's 20. Okay? So when we look at that list, do you see duplicates in there? Jenny, are there any duplicates? You think like a computer then. Anybody else think there might be duplicates in there? What does John think? Which ones?
Probably duplicates, but it's hard to tell.
It's hard to tell.
Tony Spencer is actually.
You forgot to misspell your name the second time.
Yeah.
I didn't want to misspell it.
Oh, okay.
I knew how to spell my name.
Okay.
So if I told you that this data came from multiple sources, and some of it was somebody else had keyed it in, somebody else had,
Family history.
yeah, family history, let's say it is. What do we think about Tony Spencer? He's in there twice. The name's spot on match, but the age is off by a little bit. One says 48, one says 46. We know he's 22, but we also know he lies a lot about his age. So I'm going to just wager a guess and say that's a match. I'm going to call that a match. Jim Byer, 53, and Jim Byer, 53, same age. The only thing that's different is his last name is a little funky, but I can see that happening. Sometimes he forgets how to spell his name. So that could be a match as well. And I think John Worthington is also a match. That's a pretty common mistake for someone who's entering his name to put the H in. And 41 to 39, that's pretty close, right? So we'll say that that's close. So what we want to do is we really want a distinct list of people. So we're going to use the distinct operator in the link library to make a distinct list of people. So let's go ahead and run that. All right. How's that look now now that we have a distinct list of people?
It's the same.
It's the same. What? Does the distinct operator really not work? Well, let's look up at our numbers there. 52, 20, 19, 37, and 20. We have a duplicate in there. I just need to check, make sure distinct actually works. Microsoft shipping this broken garbage. All right. Hey, that worked, right? And we have a distinct list because 20 only appears in there once. So distinct works. So what's wrong with it? How come it doesn't work on our people? Any ideas why?
You haven't defined the compare, and therefore it falls back to your default compare, which is looking at memory address.
Right. Exactly. So for reference types, for value types, it's pretty simple. It can just look at the values and compare them and see. But for reference types like person, that's a little more complicated. It doesn't know how to compare that very well. So
none of those are exact matches.
yeah, that's what you say. Because you think like a computer. But my wife would look at that list and say, you got duplicates all over in there. Those are the same people. That's the same people, right? So we'll put a raw list in here. So we need to teach the computer a little bit about how to make things distinct. And the one way that we can do that is if we look at this distinct, there's an overload, and it says, I accept an I equality compare of person. Oh, so where do I get one of those from? I have to write it. Of course I do. I have to do everything myself. So we're going to create a new class called person compare. I'll put it over here, even though it's its own class, I'm just going to put it in the same file. So a person compare, it has to implement the I equality compare of person. So by default, there's two methods, equals and get hash code, that need to be implemented. And when you first implement that, it throws a not implemented exception. Notice on the equals, there's a person X and a person Y. It's going to compare two different persons. So we get to set the rules. What makes a person equal? So for now, we're going to start simple and say, if they have the exact same person ID, even if the values are different, we're going to call that a match. And in order for this to operate, we also need to have a hash code that it uses. So let's just do that. Now we have a person compare, and let's pass in a new person comparer. Right? Let's see how well this works. Okay, so there's our raw list and our distinct list. So who dropped out? So Jim Beyer dropped out because his person ID was 3 and 3, and also Travis was 5 and 5. So the problem with Travis is I'm not 100% convinced that these two are a real match because the ages are so far apart, 36 and 20. I can buy 35 and 36 because that's pretty close, but 20, that's a long ways off. So I don't really want that to be a match. I don't even care if the ID is a match or not. I think that's a mistake.
Might be a son with the same name.
It could be a son with the same name, and never mind that he has the same person ID. So I'm going to create a little bit more complex rule. In my rule here, what I want to do is say, well, if the first name and the last names are a match, and the age difference of the people is within 3 years, then return true, otherwise return false. I need to adjust my hash code just a bit. Okay. And let's see if it made any difference. Now it may not, because Travis Mayer, the first name and last name don't actually match, right? Because they were spelled differently. So that's one way that it dropped out. So it didn't match this one, this 35 and this Travis Mayer 36, because the names were spelled differently.
It matched the Tony Spencer.
Did match the Tony Spencer. Got rid of that one because the names were spelled exactly the same and the ages were only 2 years apart. So, okay, that's pretty cool. So let's get really fancy. I happen to have in my helper library here something called a double metaphone. It's an implementation from a guy named Lawrence Phillips. I think we often refer to it as something called sounds like. Okay? So what I want to do is pull in sounds like. So this is kind of fun because we can make our compares as complex as we want. And the other thing I want to do is I want to make, in fact, let's just undo that. We're going to keep this one around, and we'll just create a whole new class called fuzzy compare. Because somewhere in your life, once in a lifetime, you should every so often write a class that has the word fuzzy in it. It just makes you feel good. All right, so here's my fuzzy compare. I've made it so that you can actually, by default, we're say it's a fuzzy match if the age is within 3, but I've also created a constructor overload that allows me, when I create that compare, to hand in any age difference I want, and I can change that on the fly. The other thing down here is I use this double metaphone. Double metaphone.compute keys of the first name and the last name. And basically what that does, it's called compute keys, but let's call it sounds like. So it'll take two different names like Travis and John with the H, and it knows using this algorithm that those are roughly, they sound alike, and that'll be a match. Okay? So instead of just doing on pure spelling, we're just going to do it on sounds like. So let's just do fuzzy person compare. What's that? Person, what did I call it? Person fuzzy compare. Dang it. Okay, thanks.
You pass an age, you're going to go with default.
I'm going to leave the default for now. So now look at our new list. So it found our two duplicates, our Travis Mayer and our Travis Mayer. Tony Spencer and Tony Spencer, obviously. And Jim Beyer dropped out. John Worthington and John Worthington, we got a single instance of that. And then we had this one other Travis Mayer down here. Are you happy with that? Is that better?
It always keeps the first of the two matches.
Yes, it always keeps the first of the two matches. That is correct. That's the way the distinct operator works. So wouldn't it be kind of nice to be able to know which ones were the duplicates that got rejected? That'd be kind of cool too. All right, I certainly don't want to write that. So let's go. We're getting towards the end here. This is good. So I have this. I didn't write this. Oh no. Source does not needs system.link. I actually stole this code right out of the link repository. Oddly enough, there is no get duplicates in the link library today, but it's in the link library source code, so go figure. So I went up in the source code and I saw that's like, hey, that's pretty cool. That'd be nice to have. So I pulled it in, and you can see what it's doing. They have a bunch of different overloads for it. There's one that just accepts IEnumerable source, one that says that you can pass in a selector, one that passes in a comparer. We'll actually be using the one that has the comparer because we want to feed it our comparer. So let's give this a try. Duplicates. So the distinct list was a distinct list, but this one is our get duplicates. I'm going to still pass in our new person fuzzy comparer. And you'll notice that it doesn't actually quite work right, but it's close enough. What's that? It's not the duplicates that doesn't work right. It's actually my comparer, because my hash code doesn't quite represent what my equality portion is. And the get duplicates depends on the hash code. And so since they're kind of a mismatch, it's a little bit of a lie. So you can see there with Travis Mayer, Tony Spencer, John Worthington, and Jim Beyer, those are the ones that it picked off out of the reject list. It kept these, rejected those. So pretty fancy stuff. So let's do one more thing. Let's change the age. What was the age spread for Travis? 16. So if we say like 17 years. I think this is where it will show the error. No, it picked it up. I'm surprised. Yeah. There's some implementation. I can't remember. There's some example where you run it. It doesn't quite work right. And it's because the way I've set my hash code doesn't quite represent what the equality comparer is doing. Okay. We're at the end. I know it doesn't say that we're at the end of time, but we're actually out of time here. So that's a fun little journey kind of through. There's some really cool things you can do with link extensions that we barely scratched the surface. Like you can do union and concatenate. I can take two different lists and join them together, join them to make a distinct list. Concatenate will just stick two lists together. Union will say, find the intersection of distinct people out of the two lists and put them together. Again, that's where the comparer comes in. If you want to really do a union like that, you'll need a custom comparer to make that work correctly. So a couple of other bonus extensions in here. I'll just pull these over so you can look. We won't look at them today, but I created an extension method wrapper for the parallel for each, so that you could just take an IEnumerable of items and do a dot parallel for each, pass in an action, and it'll execute that action in parallel. So parallel is kind of cool because like if you have a lot of actions you need to process on a really, really, really long list and you want to do it as fast as you can, it'll spin up multiple threads and do that for you. And the syntax is super easy to use, and it hides all of the complexity of threading from you. The downside is this. If you need that list to come back in a specific order, you could be in trouble. Parallel for each just executes it on a thread, and when the thread's done, it returns back. And so, order can be a little bit wacky on that. So, and then here's our for every. It's just like our for each, but you notice instead of returning void, it returns an IEnumerable of t. So before, when we wanted to do a .2 console on that one, it didn't work. This one would return it, so we could chain them together like that. Okay, I think that's enough for one day. Dynamic is pretty cool. I'd love to look at that in the future. If anybody wants to present on that, that would be kind of a cool topic to look at in the future is dynamic. Basically, with the features that we've kind of looked at today, and we barely touched it. We haven't looked at things like expression trees and deferred execution and a whole bunch of other really cool features that are a part of this because we just don't have time to get to it. Combine all of the stuff that we kind of looked at today with dynamic, basically your JavaScript. So we can write JavaScripty style stuff within C#. And the reason that's kind of important is a lot of times we're wanting to do interop with functional languages and with dynamic languages like Python or with JavaScript. Those keywords will let us do that interop with it very, very easily and simply. So we don't have time to dig into that, but that's something that we can look at in a future forum, and we can do the part 2. So everybody, thank you, and we'll see you guys next month.